I bet you didn't know that Io, one of Jupiter's moons, is the most volcanically active world in our solar system. Welcome to Cosmic Chronicles, where we explore the wonders of the universe. Io is a moon of Jupiter, one of the 4 largest moons discovered by Galileo Galilei in 1610. It's a fascinating celestial body that has captured the interest of astronomers and scientists for centuries. It's about the size of our own moon, with a diameter of approximately 3,643 kilometers. Despite its similar size, Io is vastly different in terms of its geological activity and surface features. But don't let that fool you. Io is the most volcanically active world in our solar system. Its surface is dotted with hundreds of volcanoes, some of which are constantly erupting. Imagine hundreds of volcanoes erupting at once, spewing lava fountains kilometers high. That's Io. The intense volcanic activity is driven by the immense gravitational forces exerted by Jupiter and its other moons, creating tidal heating within Io. These eruptions are so powerful they can be seen from Earth with large telescopes. Observatories around the world often capture these spectacular events, providing valuable data for scientists studying volcanic processes. Io's volcanoes are constantly reshaping its surface. The landscape is in a state of perpetual change, with new lava flows covering old ones, creating a dynamic and ever-evolving terrain. They paint the moon in vibrant shades of yellow, orange, and red. These colors are due to the various sulfur compounds and other volcanic materials that blanket Io's surface. This makes Io a truly alien and fascinating world. Its unique geological activity and colorful landscape make it a prime target for future exploration missions, as scientists seek to understand more about this extraordinary moon and its place in our solar system. Scientists have been puzzled by Io's intense volcanic activity for over 4 decades. This small moon of Jupiter has been a subject of fascination and mystery ever since its discovery. Its surface is dotted with hundreds of volcanoes, some of which are among the most active in the entire solar system. We first saw these eruptions up close in the late 1970s, thanks to NASA's Voyager spacecraft. The Voyager mission provided humanity with its first detailed look at Io, revealing a world unlike any other we had seen before. The images sent back to Earth were nothing short of spectacular. The images were breathtaking, but they also raised a big question. How could such a small moon generate so much heat and volcanic activity? The sheer scale and intensity of the eruptions were beyond anything scientists had anticipated. What is fueling this incredible heat inside such a small world? Io's volcanic activity is not just a minor feature, it dominates the moon's landscape. Massive lava flows, towering plumes of volcanic gas, and frequent eruptions are all part of Io's dynamic environment. Io is far from the Sun. In fact, it orbits Jupiter at a distance where solar energy is minimal. This means that the Sun's heat cannot be the primary source of Io's volcanic activity. It receives very little solar energy. The amount of sunlight that reaches Io is not enough to account for the intense heat and volcanic activity observed on its surface. So, what's causing these volcanoes to erupt with such ferocity? Scientists have proposed several theories over the years, but one of the most widely accepted explanations involves the gravitational interactions between Io, Jupiter, and the other Galilean moons. This question has been a major mystery in planetary science. The tidal forces exerted by Jupiter and its neighboring moons create intense friction within Io, generating heat through a process known as tidal heating. This internal heat is what powers Io's relentless volcanic activity, making it one of the most geologically active bodies in our solar system. Studying Io is no easy task. It's incredibly far away from Earth. Sending spacecraft there takes time, resources, and advanced technology. For years, scientists have relied on telescopes and data from passing spacecraft like Voyager and Galileo. While these missions provided valuable information, they couldn't solve the mystery of Io's heat source. We needed a closer look, and a mission dedicated to understanding this intriguing moon. In 2011, NASA launched the Juno spacecraft. Its primary mission was to study Jupiter, but Juno also had Io in its sights. After completing its primary mission, Juno adjusted its orbit to make close flybys of Io. Juno is equipped with a suite of instruments designed to probe the interior of planets and moons. These instruments allow us to study Io's gravity, magnetic field, and volcanic activity in unprecedented detail. Section 5. Unlocking Io's Secrets, the Power of Gravity and Tides. Juno's instruments revealed something remarkable about Io's interior. They showed us that Io's insides are constantly being churned and heated by the immense gravitational pull of Jupiter and its other large moons. This gravitational tug-of-war creates friction deep inside Io. Imagine squeezing a stress ball, it heats up. The same principle applies to Io, only on a much grander scale. This process is known as tidal heating. Section 6. A breakthrough discovery. Solving the volcanic mystery. Juno's observations confirmed that tidal heating is the engine driving Io's extraordinary volcanic activity. The gravitational dance between Jupiter, its moons, and Io generates enormous amounts of heat within Io's core and mantle. This heat melts rock into magma. The magma then rises to the surface through a network of underground channels, erupting as spectacular volcanoes. The mystery, after 44 years, was finally solved. Section 7. Implications for the solar system and beyond. In this section we delve into the far-reaching consequences of our understanding of Io's volcanic activity, and how it extends to other celestial bodies within our solar system and even beyond. Understanding Io's volcanism has implications that reach far beyond this one moon. Io, one of Jupiter's most fascinating moons, is the most volcanically active body in our solar system. Its intense volcanic activity is driven by the immense tidal forces exerted by Jupiter's gravity. These forces create frictional heat within Io, leading to its spectacular volcanic eruptions. It helps us understand how tidal forces shape celestial bodies throughout the solar system and beyond. Tidal forces are not unique to Io. They play a significant role in the evolution and geological activity of many other moons and planets. By studying Io, scientists gain valuable insights into the mechanics of tidal heating and its effects on other celestial bodies. Tidal heating could be a key factor in the potential habitability of icy moons like Europa, another of Jupiter's moons. Europa's icy surface hides a vast subsurface ocean, kept liquid by the heat generated from tidal forces. This ocean is one of the most promising places to search for extraterrestrial life within our solar system. And Enceladus, a moon of Saturn. Enceladus, with its geysers spewing water vapor and ice particles into space, also harbors a subsurface ocean. The heat from tidal forces keeps this ocean in a liquid state, making Enceladus another prime candidate in the search for life beyond Earth. These moons likely harbor vast oceans of liquid water beneath their icy crusts. The presence of liquid water is a crucial factor in the search for life, as it is essential for all known forms of life. The discovery of these subsurface oceans has revolutionized our understanding of where life might exist in the universe. Could tidal heating provide the energy needed for life to exist in these oceans? The energy from tidal heating could create the necessary conditions for life to thrive, even in the absence of sunlight. This raises exciting possibilities for the existence of microbial life, or even more complex organisms in these hidden oceans. As we continue to explore and study these distant worlds, we may one day find that life is not unique to Earth, but is a common occurrence throughout the cosmos. Section 8. The future of Io exploration, unraveling more mysteries. Juno's mission has been extended, allowing for even more detailed observations of Io. And there's more to come. NASA's upcoming Io Volcano Observer mission will dedicate itself entirely to studying Io's volcanoes and their impact on Jupiter's magnetosphere. These missions will undoubtedly reveal even more about this fascinating world, refining our understanding of Io's volcanism and its role in the Jovian system. Section 9. Io, a testament to the wonders of space exploration. Io's story is a testament to the power of human curiosity and our relentless pursuit of knowledge. It highlights the importance of space exploration in expanding our understanding of the universe and our place within it. As we continue to explore our cosmic backyard, we're bound to encounter even more mysteries and wonders, and with each discovery, we gain a deeper appreciation for the beauty and complexity of the cosmos. Thank you for watching Cosmic Chronicles. Don't forget to like, subscribe, and hit the bell icon for more fascinating journeys through the universe.